Update the above to find A instead of C. You already used this, which we did for Pythagoras theorem. The question is now saying, instead of finding C here, we should update this to find A. That means we have to reverse it. So what we are saying is this. If this is a right angle triangle, and this is C, this is A, this is B, we are looking for C in this function. We say C is equals to square root of A square plus B square. To find A this time, that means we have to say C square, move this one to this side, equals to A square plus B square. Then C square minus B square is equals to A square. Then A now is equals to square root of C square minus B square. This is what the system expects us to do. C square minus B square, you find the square root. I will simply copy and paste the same thing. To update the function, just a drop function, put the name of the function, which is what? This one. But in between here, you have to put if exists. This is like you are deleting, then you recreate. It's the meaning. So you put your semicolon. That is just the meaning. You delete, you recreate if you want to update. So the next thing I will do now is, before we define A and B, now we define B and C. Okay. Then this is what I will return. This time, instead of C, I will now declare A. I will put A here now, which is C multiplied by C minus B multiplied by B. Then I will return A. Every other thing remains the same. So that means this one is no longer for C, is now for A. If I run this, okay, correct. The next thing, let me copy this. I'll draw somewhere for you so you can use it if you want to use it. So now let's select Pythagoras. Those values are, let's say, 2 and 4. Now we are getting A. This is not what? C anymore. And remember, definitely is A, because if you look at what we have done, this is C, this is B. And C is always what? The biggest. Look at it. If you look at this, without being told, you know that the longest one is 4. While this one is 2.65, this one is 3. So there's no way this number or this value will ever be bigger than whatever that will be here. Even though we reduce this one to 1. Okay, let's try this. See, no. Why? Because there's no way that in Pythagoras theorem, you are saying here that the longest side, which is 1, is now smaller than this one, 3. It's not possible. This one will be null. It will not exist. That is the meaning. This one must always be bigger. Assume I put one here, and let me put one here, I put 2 here. Whatever that is coming will be smaller than this value. Even if I put one here now, one here, which is not possible, see, that one will be 0. So if I put something like 6 here, I put 3 here, definitely it will be like this. This is the one that will always be bigger than this and this. This is always bigger than this and this in Pythagoras theory. You see what we have done is perfect and is correct. Hope you are enjoying this class. Let's go straight to the next class.